All right. So here I am talking about wiggling springs around, and you can imagine it could be a skipping rope too. If I took a skipping rope and I tied it to a pole, there you go. That would be that would be a real demo. Can you imagine that it? Well, what do you think this person just did? I stole this from a textbook, obviously. What did they just do in the snapshot just before what we're looking at here? Yeah. Yeah, look at that. They must have. They must have like jerked that skipping rope up, right? That's how you send a pulse. This person sent what's called a pulse. I want to circle that. That is a pulse. It's a single wave burst. That's my nice slang little wording for what a pulse is. I've heard other people call it a traveling energy packet. Just a pulse. How'd you send it? Just a jerk. All right. So, oh, by the way, is this a transverse pulse or a longitudinal pulse? Transverse. This is a transverse pulse. Now, if you want to have, this is also transverse, but if you wanted to have a transverse sinusoidal wave, what would you have to do? What's this person got to be doing? Yeah? Yeah, continuous repetitious jerks, right? This one here is a single one. This one's over and over again, right? And at equal time intervals even. So we're saying if you repeat the pulse, repeating pulses, and even more specifically at equal time intervals. That's going to send a transverse traveling wave, a sinusoidal wave. What is this guy doing? What the heck is this thing? Anybody decode what this cartoon is supposed to be? Yeah? Yeah, he's kind of pumping air. Look at this. He's holding on to like a handle, and it looks like it's like a piston, and there's a cylinder here. Can you read this? Is this person got an up-down motion or an in-out motion? Yeah, it's an in-out. They're like pushing in and then pulling out on this piston. And what that's doing is creating density regions and low density regions. Remember, we called them compressions and rarefactions. And if I was going to do this, in art class, I learned about stippling. I would say that means that when it's compressing as a stippler, I would be illustrating air particles getting packed close together. That would be the compression regions. The rarefaction regions would be low air particle density. See how that's kind of like the slinky idea from before? Instead of it being slinky coils being packed together or spread apart for compressions and rarefactions, now I'm talking about air particles being packed together or spread apart. By the way, this kind of a longitudinal wave, this is how sound waves travel. This is exactly what sound waves are. This person here pushing in and out on this piston, this isn't going to necessarily make something that we can hear because they'd have to be pushing in and out on it about, what is it, like 20 times per second or more. Anywhere from 20 times per second to 20,000 times per second. That's our auditory range. So the frequency on this would have to be somewhere between 20 hertz and 20,000 hertz, 20 kilohertz. If I could hear this, if I was going to hear this as sound. Anything slower than 20 hertz, and it's just going to feel like a gentle breeze gets blown out this end every time he pushes. Again, does that make sense to people, like mechanically? Trying to engage in like this playground kind of thinking, like we can thinking of these as toys that people can play with, right? So again, let's put this into words. Repetitive compressions and decompressions. And remember, we don't really call them decompressions, we call them rarefactions. That's the proper name. And we got to be specific, at equal time intervals. And that would make a longitudinal airwave. And if you do it fast enough, you can hear it. Now, could a human really get to the point where you could hear it? I don't know what your click frequency is, because I know some people play these video games where you got to click really fast to, I don't know, kill the fish or something like that. You know, these silly Roblox games or something. But you guys know those kinds of games? And they'll go get click bots or something so that they can click it really fast so they get the rideable, flyable cow or something. You know, some of you people are these people, right? Anybody get the rideable, flyable Cerberus? Or no? One of my kids was bragging about their flyable cow. Remember back in the day when I had that flyable, rideable cow? I was like, oh my gosh, really? That was a thing? Hands in the air if you ever had a rideable, flyable Roblox thing. Yeah, Pet Simulator? Is that what it's called? Anyway, all right. Anyway, if you're somebody who needs to click really fast, you know that 20 hertz is a lot, right? If you can't click at 20 hertz, you definitely can't push this plunger in and out at 20 hertz. This is getting beyond human capacity. And yet, hold on. Shh. Aren't y'all hearing me right now? And if this is the basis for what a sound wave is, doesn't that mean that right now, if you can hear me, somehow I'm compressing and decompressing air somewhere between 20 hertz and 20,000 hertz? If you can hear me, that's true, right? Can you guys put your hands on your throat for a second? And go, just do it. That's the instrument, honey. That's it. That's the thing that's pushing in and out within that frequency range. You're doing it, right? Every time you talk. In fact, if you're listening to me on the YouTube right now, you got a speaker on your desk or in your earphones or whatever, that device is pushing in and out on air at that frequency range. That's how you're hearing things. There's actually a little diaphragm that's pushing in and out. It's using an electromagnet, and it's pushing the speaker in and out within that frequency range. That's how you're hearing everything you hear electronically, every speaker system. So whether it's whatever your throat's doing, could even be, hey, put your hands on your chest. Go, Can you feel it in your chest when you put your hand on your chest? There must be compressions there too. And in fact, can you guys repeat after me? My body is a rich instrument. 3, 2, 1. Your body is a rich instrument. Lots of parts of your body vibrate, and they make those frequencies that you can hear, compressions and decompressions, compressions and rarefactions. Okay?